So on number 1, locate x. Where's x? Exponent. What is the rule of thumb? If it's up in the exponent, what do we need to do? Not swirl it. Take the logarithm of both sides to get x out. Yep. So we're going to use log of 7 to the 5x equals log of 120. Make sure you do it to both sides. If you leave one out, somebody will get their feelings hurt. Do it both sides. Okay? Then I'm going to incorporate my power rule and move it to the front. So I have 5x times the log of 7 equals the log of 120. What else could I divide by? What else? I mean, we could do log 7 first, yeah. Sure. So 5x equals whatever this is going to be, I don't know. Log of 120 divided by log of 7. Okay, I get like 2.460, on and on and on. Then what would I do? Divide by 5. So I'm not going to cut my decimal off until I'm completely done with my question. Use your calculators to remember this. So I get x is equal to 0.492. Okay? Do y'all remember doing this in Algebra 2? Maybe? Yeah, a little bit? All right. Number 2, totally different question. X is in the exponent, but what do you notice about this one?
There's x squared.
There's an x squared. And they're both sides of the equal sign are e to something, aren't they? We have that property that says if the bases are the same on each side, what happens to them? The bases will cancel out. So that's real handy. The e's fall out, but then I still have x squared plus 3x equals 18. Now I got to solve this.
Would you like this?
Put it in that drawer over there. So I'm going to move my 18 over. Equals 0. Now we're back to quadratics. How can we solve that? Yeah, will this factor? That's the easiest way. Is this one going to factor? Yeah. X what? Plus 6, x minus 3. You're on the right track. All right, x plus 6, x minus 3. That means if I solve this, x will equal negative 6, and x will equal positive 3. It's to the second power, so there should be 2 solutions. So there they are. All right, you got to know your properties. Same bases on each side. As long as that's all that's going on each side, then you can just cancel them out. Okay? Lastly, number 3. This one has multiple logarithms, right? So you don't even want to try to solve it when you got multiple logarithms on both sides. You want to condense it down using those properties we talked about yesterday, right? So the issue is this side over here. It's got 2 logarithms. They're separated with a plus sign. So how could we bring them back together? Product rule, right? The reverse of the product rule would say, so the left is going to stay the same. This one would say, okay, x plus 2 times x minus 1. Product rule, I could take the plus sign out and just multiply. Now, similar to number 2, notice the bases here are the same, aren't they? And what happens when they're the same? They'll cancel out real nicely. So now we're just down to x plus 10 equals x plus 2 times x minus 1. Now we got some solving to do. How are we going to go about solving this one? What's the word? What's the word?
Well,
Foil them out, right? All right, so let's FOIL this. We get x squared minus x plus 2x, so that'd be a plus 1x minus 2 equals x plus 10. Then what?
we move the 10 and x forward.
I'm going to move these over, so it's going to be a minus x and a minus 10. So I'll end up with x squared minus 12 equals 0. Kind of gross, isn't it? We're not done. Yep. So move the 12 over. So x squared is equal to 12. So then if I take the square root of both sides, 2 square roots of 3, plus or minus 2 square roots of 3, right? Now, that took a lot of work, right? But you got to start with those properties of logarithms. Now, one thing you're going to find out, you got to watch your video carefully. And again, I know I'm talking a lot today, but that's because I'm going to see most of you, I won't see most of you tomorrow, and you got to quit on Monday. So you've got to keep up. You got to get your work done. All right. I appreciate that you're involved, but you got to keep up. All right. So what you're going to find out though is, sometimes we'll get multiple answers here, right? Positive, negatives. Sometimes not every solution you find will actually work in the question because you cannot take the logarithm of a negative number. So if I look at this for a second and I think just about the positive 2 square root of 3, that's positive, right? Positive plus positive is going to be positive, so it's going to work in this logarithm over here. Positive plus to something else, it's fine. Positive 2 something minus 1 is going to remain positive, isn't it? In this little piece of the puzzle. Y'all tracking with me here? 2 minus 1 is still a positive 1, isn't it? I'm just rounding here. So it would work here, it would work here, it would work here. That's the positive 2 squared root of 3. Y'all follow me at all? What I'm saying? Anything? All right, now, then I need to investigate. Will the negative 2 square root of 3 work everywhere? Okay, so negative 2 square root of 3 is around negative 3-ish. Okay, that's all you got to know. So then I go back over here. If I put a negative 3-ish in here and I add 10, will this piece right in here remain positive? Yep, works here. If I put in a negative 3 something in here, will this remain positive?
No.
Mm-mm. What about here? No. So in reality, this one, although it looks like it has 2 answers, it doesn't. The only solution that actually works is the positive 2 square roots of 3. So you're going to have to really be careful, and you have to do extra thinking on that. Okay? If you try to put it in your calculator, it'll say error, and you'll be like, what the heck? Well, you can't take the log's negative number. Watch your video carefully because I talk about it in there as well.